The bombardier's gloved hand hovers over a brass knob, frost forming on his oxygen mask as -40-degree air seeps through every rivet of the B-17's plexiglass nose. Below, through broken clouds, the Ruhr Valley spreads like a gray tapestry of smoke and steel. His eye presses against a rubber cup, and through the eyepiece, crosshairs dance across factory rooftops with mechanical precision. He touches nothing. The device calculates wind, altitude, airspeed, drift. 15 tons of bomber and 10 men hold their breath as mathematics becomes destiny. The toggle switch clicks. Bombs fall. 4 miles below, a ball-bearing plant, one that has survived 37 previous raids, ceases to exist. The bombardier has never met Carl Norden, but in this frozen moment of perfect destruction, he is the instrument of one man's obsession with absolute accuracy. This is not a story about bombs. This is a story about vision so consuming it bordered on madness, about an engineer who believed he could bend the chaos of war into pure geometry, and about how a device no larger than a suitcase became America's most protected secret, a machine so revolutionary that men carried pistols with orders to destroy it rather than let it fall into enemy hands. By 1945, the Norden Bombsight equipped nearly every American bomber over Europe and the Pacific, and its creator had become both celebrated genius and controversial figure, a man whose invention promised to make war more humane by making it perfectly precise. The German High Command called it the most dangerous piece of equipment the Americans possess. The Japanese offered bounties for intact specimens. Allied planners spoke of it in whispered reverence, as if accuracy itself had been captured and caged in brass and optics. But the machine's true story begins not in wartime desperation, but in peacetime obsession. In the mind of a Dutch immigrant who looked at the imprecise horror of aerial bombing and saw not inevitability but engineering failure, Carl Lucas Norden arrived in America in 1904 carrying a diploma from the Swiss Federal Institute of Technology and Convictions that bordered on religious certainty. Precision was not merely preferable, it was moral imperative. In the sprawling chaos of early 20th century New York, he found work designing gyroscopic compasses, his Swiss-trained mind revolting against the casual tolerances American manufacturers accepted. A shaft might be close enough. A bearing might be within range. For Norden, these phrases represented moral collapse. Either a mechanism worked with mathematical perfection or it failed, and failure was simply unacceptable imprecision waiting to manifest. His colleagues found him difficult, humorless, obsessive. His designs, however, worked with uncanny reliability. When the United States entered the Great War, the Navy took notice of this meticulous foreigner whose gyroscopic stabilizers never drifted, whose calculations accounted for variables other engineers dismissed as negligible. In 1920, the Navy approached Norden with a problem that seemed insoluble. Aircraft had become weapons, but aerial bombing remained essentially random violence. Pilots flew over targets and released bombs by guesswork and prayer, hoping wind and gravity and luck might align. Accuracy meant hitting within a quarter mile of the aim point. Usually, bombs simply vanished into empty countryside, wasting ordnance and achieving nothing but noise. The Navy wanted better. They wanted precision. They had come to the right man, though they could not have known they were unleashing an obsession that would consume the next 15 years of Carlo Norden's life and reshape the very concept of strategic warfare. Norden listened to the Navy's requirements and immediately dismissed them as insufficiently ambitious. They wanted improved accuracy. He wanted perfection. They spoke of hitting a ship from 1,000 feet. He envisioned hitting a specific point from 5 miles up. To understand the magnitude of this ambition, one must grasp the chaos Norden proposed to tame. A bomber traveling at 200 miles per hour experiences winds that shift by altitude and direction. The Earth curves beneath it. Air density changes with temperature and pressure. The bomb itself, once released, becomes a ballistic object subject to aerodynamic forces that vary with velocity and angle. Previous bomb sites were essentially glorified protractors, static devices that assumed conditions never present in reality. Norden proposed something unprecedented, a mechanical computer that would continuously calculate the solution to a differential equation with dozens of variables, updating its answer 30 times per second, accounting for every deviation from the theoretical, and delivering its conclusion with such precision that a bombardier could, in Norden's often repeated phrase, place a bomb in a pickle barrel from 20,000 feet. His colleagues called it impossible. Military officials called it fantasy. Norden called it inevitable and locked himself in his workshop. What emerged over the next decade was less a device than a philosophy made metal. The Mark 15 bombsight, officially designated as such, though universally known simply as the Norden, resembled a mechanical brain mounted on gyroscopic gimbals. Two main components worked in concert: the stabilizer, which used gyroscopes to create an artificial horizon immune to the aircraft's motion, and the sight head, where optics and mechanical computers converged to solve the bombing problem in real time. The bombardier would identify his target through a telescopic eyepiece offering magnification up to 8 times. He would feed initial data into the sight: altitude, airspeed, wind direction. Then came Norden's breakthrough. The sight itself would take control of the aircraft during the bombing run. Through an autopilot connection, Norden designed specifically for this purpose, the bombsight became the pilot during the final minutes of approach. The bombardier, eye pressed to the sight, would make minute adjustments using control knobs, centering crosshairs on the target. These adjustments fed directly into the bombsight's mechanical calculator, which measured the rate at which the target appeared to move, calculated the differential, factored in all known variables, and continuously updated its solution. The bombardier did not aim the bombs. He aimed the airplane using the bombsight as intermediary. The aircraft became an extension of the machine, and the machine became an extension of pure mathematics. When the sight's calculations determined the precise instant of release, accounting for the bomb's ballistic trajectory, the aircraft's motion, wind drift, even the curvature of the Earth on long drops, it would automatically trigger the release mechanism. The human operator was simultaneously essential and subordinate, the biological interface between target acquisition and mechanical perfection. The first test results seemed to validate Norden's obsession. In calm conditions over static ranges, bombardiers using the Norden sight achieved accuracy that military observers found difficult to believe. Bombs landed within feet of aim points from altitudes previously considered impossible for precision work. The Navy and soon the Army Air Corps saw the future of strategic bombing. Here was the solution to warfare's most vexing moral equation: how to strike military targets while sparing civilian populations, how to destroy an enemy's capacity to make war without descending into the indiscriminate slaughter that had characterized aerial bombardment since its inception. With perfect accuracy, wars could be won through surgical strikes against factories, rail yards, oil refineries, the sinews of military power rather than the flesh of cities. But Norden himself recognized that his machine's brilliance created a problem of security without precedent. The bombsight contained innovations that took years to develop: the gyroscopic stabilization system, the mechanical computation methods, the synchronization between optics and autopilot. If this device fell into enemy hands, if its principles were understood and replicated, American strategic advantage would evaporate. More troubling to military planners, an enemy equipped with Norden-level accuracy could strike American targets with devastating precision. The machine that promised to revolutionize warfare also threatened to democratize that revolution in ways that terrified strategic thinkers. Thus began one of the most elaborate security operations in American military history. The Norden bombsight was classified higher than top secret, a designation that barely existed in the early 1930s. Bombardiers trained with the device were sworn to secrecy under threat of treason charges. Each sight was fitted with thermite charges that could be triggered to melt the mechanism into slag if capture seemed imminent. Bombardiers carried pistols with explicit orders: destroy the sight at all costs, even at the cost of the aircraft and crew. The device was transported under armed guard, stored in vaults between missions, and removed from aircraft immediately upon landing. Its very existence was classified. Specifications were compartmentalized so thoroughly that engineers working on different components often had no idea how their pieces fit into the whole. Carl Norden's company, based in a nondescript building in Lower Manhattan, became a fortress of industrial secrecy, where workers were investigated, monitored, and reminded constantly that careless speech could mean prison sentences measured in decades. Norden himself became almost fanatical about security. He trusted no one fully, documented everything in codes, and maintained personal control over every aspect of production. His behavior grew increasingly erratic, his perfectionism metastasizing into paranoia. He would halt production lines if a single component failed to meet tolerances measured in thousandths of an inch. He fired engineers for minor deviations from specifications. He refused to simplify designs even when military officials begged for easier production, insisting that any compromise in precision was unacceptable compromise in principle. The device that was supposed to win the war nearly failed to reach the war because its creator could not tolerate the imperfections inherent in mass production. By 1940, with war consuming Europe and American entry looking inevitable, the military faced a crisis. They possessed the world's most advanced bombsight, but could barely produce enough units to equip their growing bomber fleet. Norden's insistence on perfection was becoming a bottleneck in America's industrial mobilization. The solution came through a combination of pressure, pleading, and ultimately, contractual requirements that forced Norden to accept standardized production methods. Factories in New York and Indiana began producing bombsights in quantities that would have horrified Carl Norden in 1930, but that seemed barely adequate by 1942. Each unit still required over 2,000 precision parts, and each was still treated as if made of crystallized strategic advantage. But they began to flow, slowly at first, then in hundreds, eventually in thousands. Every B-17 and B-24 rolling off production lines received a Norden sight, installed in the bombardier's position in the plexiglass nose, where it gleamed with threatening complexity. A mechanical brain surrounded by a cocoon of secret classification and armed guards. Then came the testing ground that mattered, actual combat over Europe. The 8th Air Force bombardiers who first used the Norden in combat operations over occupied France and Germany carried expectations shaped by years of training range success. They had been told, repeatedly, that they possessed the most advanced bombing system on Earth. They had placed practice bombs in target circles from staggering altitudes under controlled conditions. They arrived at their combat stations believing in mechanical precision as pathway to military victory. What they encountered was the vast gulf between theory and reality, between calm test ranges and the chaos of mechanized death at high altitude. The problems began with the weather. European skies were nothing like the clear California ranges where bombardiers trained. Clouds covered targets for days, sometimes weeks. The Norden sight, for all its mechanical genius, could not see through overcast. Missions launched, aircraft climbed to combat altitude, and crews discovered their targets hidden beneath solid cloud decks. The choice became abort the mission, or bomb by radar, which offered accuracy measured in miles rather than feet. The perfect machine sat unused, its precision irrelevant against meteorological reality that Carl Norden had never factored into his equations. When skies cleared, other variables asserted themselves with lethal insistence. German anti-aircraft fire, called flak, filled the air around bombers with explosive shells timed to detonate at specific altitudes, creating clouds of shrapnel that shredded aluminum and flesh with equal indifference. The bomber stream would encounter walls of black smoke, hear the metal-tearing sounds of fragments striking airframes, feel the aircraft shudder from near misses. In these moments, the careful, steady approach the Norden sight required became an invitation to destruction. Bombardiers were supposed to hold their aircraft straight and level during the bombing run, maintaining constant altitude and airspeed while the sight calculated. This made them perfect targets. Pilots, feeling their aircraft absorb punishment, would take evasive action. Banking, diving, climbing, and every deviation threw off the Norden's calculations. The device that promised perfection demanded conditions that combat rarely provided. Then there were the German fighters. Messerschmitt 109s and Focke-Wulf 190s would tear into bomber formations, cannon fire walking across wings and fuselages, targeting the vulnerable nose sections where bombardiers crouched over their sights. The bombardier position was glass and aluminum, offering visibility and protection in roughly equal measure, which is to say, almost none. Men tried to operate delicate optical equipment while bullets and cannon shells turned their workspace into storms of flying plexiglass. Some bombardiers, under sustained attack, could not maintain the steady hand and clear eye that the Norden required. The machine demanded calm calculation, while chaos screamed through every sense. And even when conditions aligned, clear skies, light flak, fighters beaten back, the Norden revealed limitations that training had concealed. The device calculated based on data fed into it, but that data came from instruments that were themselves imperfect. Airspeed indicators could be off by 10% due to icing or damage. Altitude measurements varied with atmospheric pressure. Wind data was often guesswork, derived from smoke or cloud drift observed visually. The Norden could calculate with exquisite precision, but precision built on imperfect data yielded imperfect results. Bombs fell not into pickle barrels, but into neighborhoods surrounding factories. The moral promise of surgical precision collided with the physical reality of mechanized warfare, and civilians paid the price for the gap between promise and performance. Strategic bombing surveys conducted after the war revealed uncomfortable truths. Under optimal conditions, clear weather, light opposition, experienced bombardiers, the Norden sight achieved accuracy within a few hundred feet of the aim point. These were the conditions under which Carl Norden had envisioned his device operating. But optimal conditions represented perhaps 20% of actual combat missions. Under typical combat conditions, partial cloud cover, moderate flak, the stress of combat, accuracy degraded to a quarter mile or worse. Under poor conditions, accuracy became largely theoretical. Bombs fell somewhere in the general vicinity of the target. Their actual impact points determined more by chaos than calculation. The device that was supposed to make bombing humane through precision instead became another tool of industrial-scale destruction, its presence providing moral justification. We can hit what we aim at, for campaigns that killed hundreds of thousands of civilians. Yet the Norden bombsight remained, throughout the war, a symbol of American technological superiority and industrial capacity. When German and Japanese intelligence officers examined captured specimens, and despite all security measures, several sites did fall into enemy hands. They found themselves looking at a level of engineering that their own industries could not replicate. The precision manufacturing, the quality of optical glass, the sophistication of the mechanical computation system, these represented not just individual brilliance, but an entire industrial ecosystem capable of producing complexity at scale. German engineers produced analyses concluding that even with complete specifications, their war-strained manufacturing base could not produce Norden copies in meaningful quantities. The security obsession that had surrounded the device turned out to be partly unnecessary. Its real protection was the industrial capacity required to build it. For American bombardiers, the Norden became something more complex than merely a tool. It was talisman and burden, promise and accusation. Every mission briefing included reminders of their responsibility to protect the site. Every bombing run included the knowledge that the machine between their hands represented years of engineering genius and the hopes of strategic planners who believed accuracy could win wars. When bombs fell true and targets exploded, the Norden seemed to validate everything its creator had promised. When bombs fell wide and cities burned, the site became mute witness to the gap between technological aspiration and wartime reality. The device could not lie, but it could be blamed for expecting too much, for promising precision that circumstances rendered impossible, for making moral demands that combat could not honor. Carl Norden himself never flew combat missions, never experienced the chaos his device was meant to tame. He remained in New York, obsessing over production quality, fighting with military officials over specifications, defending his creation's theoretical capabilities while reports from combat zones told more complicated stories. In 1945, when strategic bombing surveys began quantifying actual accuracy versus theoretical performance, Norden reportedly dismissed the findings as evidence of improper training or inadequate maintenance, rather than limitations inherent to the device itself. His machine was perfect. Reality was flawed. The symbolic weight the Norden carried far exceeded its actual impact on the war's outcome. Yes, it improved bombing accuracy over previous methods. Yes, it represented genuine innovation in mechanical computation and fire control. But the war was ultimately won through overwhelming force, applied across vast fronts, through industrial production that buried enemies in materiel, through the brutal arithmetic of attrition. The Norden bombsight contributed to victory not because it made precision possible, but because it represented the kind of technological sophistication and industrial capacity that American enemies could not match. It was less a war-winning weapon than a symbol of the wealth and innovation that made war-winning possible. After the war, as jet aircraft and guided missiles rendered mechanical bombsights obsolete, the Norden's classification was gradually reduced. Devices that had been guarded more carefully than gold were sold as surplus, their secrets no longer worth protecting in an age of radar-guided munitions and, eventually, laser-guided bombs that achieved the precision Norden had promised. The man himself died in 1965, still defending his creation, still insisting that it had performed exactly as designed, if only it had been used correctly. Perhaps he was right. Perhaps the device was perfect, and the world too chaotic for perfection. Perhaps genius lies not in achieving the impossible, but in convincing others that the impossible is merely difficult, thereby mobilizing resources and will toward improvement, even if the ultimate goal remains forever beyond reach. The lasting legacy of Carl Norden's obsession is not the bombsight itself, but what it represented about a particular moment in technological history. There was a brief window spanning roughly 3 decades when mechanical computation reached its zenith, before electronic systems rendered it obsolete. The Norden bombsight stands as perhaps the most sophisticated achievement of that mechanical age, a device that used spinning gyroscopes, precisely machined gears, and optical systems to solve in real time a problem that would challenge early electronic computers. It represents faith that physical systems, if designed with sufficient care and manufactured with sufficient precision, could bend reality toward human intention. This faith animated an entire generation of engineers who believed that the right mechanism, properly designed, could solve any problem. That faith was not entirely justified, but it was not entirely misplaced either. The Norden did not make bombing perfectly precise, but it made bombing more precise. It did not spare civilians, but it did make military targeting possible where before only area bombing had been feasible. It represented an attempt, however imperfect, to impose moral calculation onto the chaos of war. The device itself had no morality. It was brass and glass and mathematics. But the effort to create it, the belief that accuracy mattered, the conviction that precision could be a form of ethical responsibility, these represented something worth honoring even as we acknowledge their practical limitations. April 1945. The war in Europe enters its final weeks. A B-17 limps home from its final mission, one engine dead, fuselage stitched with flak damage. In the bombardier's position, amid shattered plexiglass and hydraulic fluid, the Norden sight still gleams, its gyroscope still spinning, its mechanism still calculating with the precision Carl Norden had promised 25 years earlier. The bombardier has already removed the classified documents, already prepared the thermite charges just in case. The device has done what it could, calculated what was calculable, offered precision in circumstances that rarely allowed it. It has been talisman and tool, marvel and disappointment, revolutionary device and familiar equipment. It has been, in the end, what all technologies become, something less miraculous than its creators promised, something more useful than its critics allowed, something that changed the world not through its own capabilities, but through what it revealed about the capabilities of those who made it. The bomber lands. Ground crews swarm. The Norden site is removed, logged, locked away. Another mission. Another calculation. Another attempt to impose order on chaos. Tomorrow, perhaps, the weather will be clear. Tomorrow the data will be perfect. Tomorrow the bombs will fall exactly where intended, and war will become the precise, controlled thing that engineers and strategists imagine it can be. But tonight, reality intrudes as it always does, reminding us that some problems resist mechanical solution, that some chaos cannot be calculated away, that the gap between design and deployment is where theory meets truth. Carl Norden wanted to build a device that would make war more humane by making destruction more precise. What he built instead was a mirror that reflected both American genius and American faith in technological solutions to moral problems. The Bombsight that bore his name achieved everything he promised in theory, and much less in practice, which makes it perhaps the most honest monument to engineering ambition the 20th century produced. It stands now in museums and private collections, a relic of mechanical computing's golden age, and of a moment when brilliant men believed that sufficient precision could solve the unsolvable, that the right tool could make even war more just, that chaos itself might bow before mathematics perfectly executed. The bombers have long since been scrapped. The factories are silent. The bombardiers who pressed their eyes to optical sights over Germany and Japan have mostly passed. But the questions Carl Norden's obsession raised remain. Can technology make violence moral? Can precision redeem destruction? Can we engineer our way out of the ethical dilemmas that human conflict creates? The Norden Bombsight cannot answer these questions, but it asks them with the persistence of all artifacts that outlive their usefulness. Mechanical koans waiting in museum cases, reminding us that sometimes the most important thing about a tool is not whether it worked, but what we hoped it would do, and what that hope revealed about who we were and who we wanted to become.